Okay, one of the aspects that we had discovered earlier today, I am talking to people, and I'm not talking to myself, in case you're wondering. Okay, there's students out in the hallway. I just want to make sure they understand I'm not just talking to myself out here or in here. One of the things we discussed earlier today is if we start with this parent compound. Okay, I need to keep this for next hour, so we'll try to keep this as clear as possible. Okay, so when we talk about isomers, if we start with this parent compound, okay, as you may have guessed or you're writing it out, you're going to see that is C7H16. No surprise, we're talking about heptane there. Okay, so an isomer means that we're going to take a different type of route here, and it's also going to have 7 carbons and 16 hydrogens. And the easiest way to do that is when you look at that vocab sheet, just let me know if you haven't received that. I believe it's hard for me to remember what I have sent out to students. But with this, what we see happening here, when we talk about isomer, it's going to have the same molecular formula. That's what these are here, is molecular formulas, but it's going to have a different structure. So the easiest thing to do then is just take a carbon off of the end and do something like that. Okay, so when we see this, okay, that would be an isomer of the two. 1, 2, 3, 4, 5, 6, 7. There's our 7 carbons. 16 hydrogens. We got 3, 5, 7, 9, 10, 13, and then 3 down here gives you your 16. Same molecular formula between these two, but it's just a different structure. So this is an isomer of this. A different thing that you can do, okay, is take this methyl group off of here, because as you would guess, now we've got hexane. This would be 2-methyl hexane, and so on and so forth. Hopefully you can see this. I see we got a little bit of a glare as far as the camera is concerned. I gotta lower that. Okay, and we can make this 3-methyl hexane. Just take this and move it over one. Okay, now we got 3-methyl hexane, but be careful, we can't go over one more, because then we still have 3-methyl hexanes beyond the third one. Okay, another aspect that you can do, we can take this one off of the end again and just put this on a separate carbon. Now you've got 2,3 dimethyl pentane. Okay, or you can put them on the same one, 2,2 dimethyl pentane, and then finally you can make an ethyl group out of that and put them down here, C2H5. So we got 1, 2, 3, 4, 5, 6, and 7. So our hydrogens, 5, 8, 9, 10, 11, 13, and 3 more gives you 16. That's one of the aspects we talked about earlier today with isomers. Same molecular formula. All of these had the same molecular formula, but just a different structure from that parent chain of heptane. All right. I got another class coming in here in just a few minutes, so I want to get this wrapped up before they get in here. And another aspect, I'll give you a little bit of time. I want you to be able to write these out. Okay, so I'm going to draw this 6-sided figure. Okay, just do that, that. Okay, I'm going to draw another one over here. Okay, I got to clean these desks really quick, so I'll give you a little bit of time to write those down. Okay, we're about ready to get started again. All right, so when we look at these different types of isomers, or cis-trans isomers, okay, be on the back of the sheet. Isomers was on the bottom. We discussed that. And then we're talking about cis-stereoisomerism, or trans, okay? So I want you to think about is we talk about cis-stereoisomerism within a ring structure, which both of those are ring structures. Two derivatives or two substituents are on the same side, which means they're pointing in the same direction. That's one way of looking at it. Or another way with that of trans isomerism within a ring structure, two derivatives or substituents are on opposite sides. Okay? So when it comes to the same sides with cis and trans, okay, this one is trans, this one is cis, okay, because they're pointed on the right side. They're oriented the same way. Or I should say they're oriented on the same side. They're both pointing down, okay? They could also be pointing up. They're both pointing in the same direction. That is a cis isomer, but in this case, here they're pointing in opposite directions. That makes this a trans isomer. So one of the things we did earlier today, okay, I want you to think about this. Okay, I want you to try to name that compound. I need to step out for just a moment. I will return shortly. Okay, so now how we're going to name these is as follows. Okay, so I want you to think, what type of stereoisomer is that, a cis or a trans? Think about that for just a moment. But one of the things that we can do is if we were to remove these, we can name that. Okay, it's got 5 carbons and it's all single bonded. So when it's an alkane, we know that it is pentane, but it is also a ring structure. So it would have to be called cyclopentane. But we've got 2 derivatives on here. Okay, if we were to cover that one up, we know that this one takes priority. So, and that's where we would start. That would be 1-methyl cyclopentane. But now we've got 2 of them. And where are they located? Let's just keep this one as number 1. Okay, so that one's number 1. So are we going to go counterclockwise? 2, 3, or 2, 3, and 4. Okay? One of the things keep in mind, we want the lower number, so therefore this one is actually on the third carbon. And this is where it's different. Remember, we said we know that this is cyclopentane. Right? Now we've got two derivatives on there, and they're both methyl groups. Okay? And they're located on the first and the third carbons. So how we would name that then as 1,3 dash dimethyl, okay, cyclopentane, and that's one of the aspects you would have done on your paper, but we didn't want to throw the cis-trans isomerism in before that first problem quiz. So now the only thing we need to decipher, how are these methyl groups oriented? We got one pointing up and we got one pointing down. And from prior knowledge, we see something very similar here. So we would have trans 1,3 dimethyl cyclopentane. So the same can be said for these two. We know that this is cyclohexane. We've got two derivatives on there. So I want you to go ahead and think about what you would write for that. So we know we've got cyclohexane. Okay. We know we've got two derivatives. We'll just call this one number 1, 2, 3, 4, or 1, 2, 3, 4. They're both give you the same numbers. Okay. So we've got 1,4 dash dimethyl cyclohexane, and they're both pointing in opposite directions, so that is trans then. Okay, I'm about out of time here, so this is a ring structure. It's cyclobutane. We've got two methyl groups, one on the first carbon, one on the third, and since they're both pointing the same direction, either both down or both up, we would call this 1,3 dash dimethyl. Okay, remember it is a ring structure, so since it is, you can come in and sit down. Since this is a ring structure, we know that we have butane, so it's cyclobutane. Okay, then the last thing we need to denote, these methyl groups, these two derivatives, they're pointing in the same direction, so they're either both pointing up or they're both pointing down. So when that happens, the last thing we need to denote is this is a trans isomer, this one is a cis, because these methyl groups are both pointing in the same direction. So the last thing we do is put cis 1,3 dimethyl cyclobutane. Remember, the thing you got to keep in mind is when these are geometrical shapes, you name it after that geometrical shape. That's why this one's cyclopentane. That's why this one's cyclobutane, and this one is cyclohexane. That's what we had discussed in class earlier. So the rest of the week, we're going to review some of our organic reactions and those terms that were sent to you. And then our third will also be on Friday, and it's over the organic reactions and these isomers. Don't forget, the easiest way to do this is take one off of your parent chain, put a methyl group on there. Take two off your parent chain and put an ethyl group on there. And then don't forget, we've got these ring structures and how those derivatives are pointing. Are they pointing in the same direction, both up or both down, or one in either direction? And when that happens, that becomes a trans isomer, not a cis. It's very important to make that distinction, because what's going to happen is when we start talking about alkenes next chapter, that type of isomerism is going to be very important as far as naming some of those compounds. Okay? But that is still next chapter. We introduce it here at this time. Okay, so that's what we talked about in class. We'll catch up to you next time.